Even after using alpha-beta pruning and minimax algorithm, my AI was still far from an intelligent agent. I had already tweaked the parameters of the algorithm several times and I was not getting anything better. I searched around for ideas and that's when I realized the algorithmic techniques I was using have given the maximum that they can. One thing I can improve on is the heuristics that I'm using to run my algorithms on top of. Currently, I'm using just a simple count of the stones as utility value to build my state tree. It is not informative enough to distinguish smart moves from average moves, so I decided to add a more holistic utility value to the leaf nodes of the state tree. I changed the utility function to return the differences of the stones multiplied by a high weight like 50 if that particular move ends with a win or a lose. This will make sure a tree path that makes the agent win immediately will be given more importance than any other tree paths, and the state path in which the agent loses will be given much lower importance than any other tree path. Secondly, in cases where the game doesn't end within the max depth of the state tree, I'm using a more complex heuristic to evaluate the leaf node state. I used this paper to learn 6 different heuristics that can help with better utility function. First, I calculate the number of stones that are connected. The more connected the stones are, the harder to be captured by the opponent. Secondly, I calculated the number of liberties of the stones. This will make sure the agent doesn't make moves that results in losing its liberties, which will make it easier for the opponent to capture. I also calculated the number of opponent stones that my agent is surrounding. This is to make sure my agent is more aggressive in capturing enemy stones. On top of these 3 heuristics, I also calculated the mirror of these values, the number of opponents' connected stones and liberties, and the number of stones surrounded by the opponent. I gave negative weight these last 3 as it impacts negatively on the success of my agent. I ran the game several times and after adjusting weights for the new heuristic values, the agent was playing so much better. But I could see a few simple mistakes the agent was making, like here. This would be fixed if the agent makes a kind of a wall to defend its territory and infiltrate if the opponent forms a wall. So I wrote a simple piece of code to detect a wall formation and make my AI's moves accordingly. It was also interesting to see that AI was placing its stones in a pattern called I in the Go game. It's interesting because I didn't program explicitly for my AI to make this I pattern. Because of the heuristics I used and the weightages of the heuristics I assigned, it is mimicking an advanced technique that takes a long time for the Go players to learn. I was pretty impressed with how well my AI was playing and how powerful a simple state tree can be in gameplay. That concludes my series on building an AI to play Go game.